Welcome to All This Math. This is Professor Parker, and today, as you can see, we are representing the historically black college, Lincoln University, in Lincoln, Pennsylvania, which graduated greats such as Osajifo, Kwame Nkrumah, Nnamdi Ezekwe, and many others. I also attained a master's degree in educational leadership from Lincoln University back in 2015. So let's move on. Today, we're going to solve a quadratic equation using the quadratic formula. This right here, this is the quadratic formula. I highly recommend that you memorize this. Highly recommend that you memorize this. This is a very important tool that can be used in all cases to solve any quadratic equation. Now, what makes this a quadratic equation? What makes it quadratic is that the biggest exponent you see is a 2. I have x to the second power, or x squared. This is x to the first, and this could be thought of as an invisible x to the 0 power. So it really could be thought of as negative 19 x to the 0 power. But the biggest exponent you see is a 2. And even this 5 over here could be thought of as 5x to the 0 power. The biggest exponent is a 2, thus this is a quadratic. Now what makes it an equation? It's an equation because it has an equal sign on it. All right? You have information on the left side, you have information on the right side. The equal sign is the boundary, or the divider. All right? And of course, this is the quadratic formula that I already said. I highly suggest that you memorize negative b plus or minus. This plus sign over the minus sign means plus or minus the square root of b squared minus 4ac all over 2a. Now, this plus or minus sign, let me talk briefly about that. This plus or minus sign prevents us from having to write this equation 2 times. Instead of having to write negative b plus the square root of b squared minus 4ac all over 2a, comma, negative b minus the square root of b squared minus 4ac all over 2a, we just use the plus or minus sign. And since we're up here, while you're at it, if you're not already, follow the page on Instagram at All This Math. Thank you. But let's get started. So the first thing you want to do is you want to put this in what's called standard form. This is not in standard form because we do not have a 0 on the right-hand side. In order for a quadratic equation to be in standard form, we must have all of our information on the left side of the equal sign, and we must have a 0 on the right. Okay, that's considered standard form. So what I need to do is get rid of this positive 5 over here. Now, the opposite of a positive 5 is a negative 5. So what I want to do is I want to subtract 5 on both sides of this equation. So vertically, I'm going to write minus 5. And over here, I'm going to write minus 5. Right? So 5 minus 5 is going to be 0. And then negative 19 minus 5 is going to be negative 24. And you might hear Kwame in the background. It's my son Kwame. He's up. You know, still out doing his thing. So then I have 2x, which comes straight down. And then I have x squared, which comes straight down. So I have x squared plus 2x minus 24 is equal to 0. Now, this is in standard form because I have my quadratic, my linear, and my constant, my equal sign, and a 0. Now, I'm not going to try to factor this because I'm using the quadratic formula, right? I'm not going to try to complete the square because I'm using the quadratic formula. First thing you want to do when you're solving an equation using the quadratic formula is you want to identify your A, your B, and your C. Because when you look at the formula, I see B a couple places, I see A a couple places, I see C in one place. Those represent numbers from any equation. A is represented by the coefficient of x squared. There is no coefficient written. So therefore, A would be this invisible 1. B is represented by the coefficient of the linear term. C is the constant. So the first thing I recommend you do whenever you're using the quadratic formula to solve an equation is you write down what A, B, and C are. Just write them down. If you write them down, you don't have to think about it. You don't have to try to memorize them. You just know what they are. So in this case, what we're going to do is we're going to say A is equal to positive 1, B is equal to positive 2, and C is equal to negative 24. So A is 1, B is 2, C is negative 24. All right? And that's always the case. A is always whatever coefficient the quadratic term has. B is always whatever coefficient the linear term has. C is always the constant. All right? So now we go into the formula. Now, some people, they like to just jump into the formula and just plug everything in and just do the calculations. And that's cool. Over the year, I used to do that too. When I first started teaching many years ago, and I would teach the quadratic formula, I would do the same thing because that's how it was taught to me. But then I started thinking over time, I said, you know what? What if I just found out what the discriminant is? Now, you should be wondering, well, what's the discriminant? The discriminant is the value of just the part that's under the radical sign, b squared minus 4ac. So the b squared minus 4ac part, that's called the discriminant. And what the discriminant does, it tells you how many or what type of real roots or what type of roots or answers or solutions you're going to have. So if the discriminant is equal to 0, that means your graph is only going to touch the x-axis in one place. Or you'll have one answer. Just repeat it twice though, but you'll have one answer. If the discriminant is negative, that means you won't have any real roots. That means that you'll have some imaginary numbers. That means that you'll have a graph that doesn't even touch the x-axis. It might be above the x-axis or below the x-axis, but it's not going to touch it, right? If this is a positive number, then that means you're going to have two real roots. That means your graph is going to touch the x-axis in two different places. But right now, we're just trying to solve. We're not worried about graphs in this particular example, right? Because we're not graphing this. We're only solving this. Meaning we're going to figure out what value of x can be squared plus, and then added to 2 times the same number, and then subtract 19 can be subtracted from it, and it will equal 5, right? So now we know what A, B, and C is. I say we find the discriminant first. So we're going to do this. B squared minus 4AC is equal to, and we just plug numbers in. Plug numbers in and then do the mathematics. As long as we know how to use the order of operations, we should be fine. So wherever I see a B, I replace it with 2. So now I got 2 squared, right? Now, if this was a negative number, then I would want to put that number in parentheses and then put the exponent outside of the parentheses. But it's not a negative number, so we don't have to worry about that in this particular example. So then I put my minus sign, and then I put a 4. This A means 4 times A. So instead of writing 4 times A, I'm going to write 4 times 1. Now notice, it should not be written just as 41, right? This is actually 4 times 1, because 4A means 4 times A. And then times C, and what's C? Negative 24. So all I'm doing is just replacing and plugging things in. So then I apply order of operations. So then I'm going to do 2 squared. I'm going to have 4, right? And then I'm going to have negative 4 times 1, which is negative 4. And then I'm going to have negative 4 times negative 24, right? Which is going to be positive 96, right? Because 4 times 1 is 4, and 4 times 24 is going to be 80 plus 16, which is 96. And this is a negative times a positive, which gives us a negative. And then that negative times another negative gives us a positive. Because remember, in multiplication or division, in mathematics, 2 wrongs, 2 negatives, 2 wrongs make a right, a positive. All right? But only in multiplication and division. All right? Now, then I have 4 plus 96, which is going to be 100. So I have my single number, and that's my discriminant. So if I was going to graph this, this tells me, because it's a positive number, that I'm going to have 2 real roots for my solutions. All right? So now I'm going to go to the formula. And now I like the fact that I found the discriminant already, because now I don't have so much to plug in. I'm going to plug so much in when I actually use the quadratic formula. So now I'm going to do x is equal to negative b, which was 2. Now keep in mind, if your b is ever negative, that means you're going to have 2 negative signs. A lot of students like to just use 1 negative sign. They don't like to write 2 negative signs. But if the formula calls for a negative b, and then b is already negative, then what's that mean? That means you got 2 negative signs. You got a negative of a negative. So just write it down like that, right? So you got negative 2, write your plus or minus sign, write your radical sign, and then what was my discriminant? Boom, this right here. So I take that 100, throw it under the radical sign. And I draw my fraction bar. It's all over 2 times a. So then 2 times 1, because a was 1, right? And now we got negative 2 plus or minus, and now we're just going to simplify whatever we can. We're in luck because 100 is actually a perfect square. So I don't got to simplify the radical. I don't got to do all that extra stuff, and not in this particular problem. In some problems you will have to, and don't be intimidated by that. Just learn how to simplify radicals and you'll be fine. It's not a negative, so I don't got to worry about the imaginary number I. That's another thing we could talk about on another video, but we're not getting into that right now. But 100 is a perfect square. So that means that the square root of 100 is 10. And then my denominator is 2 because 2 times 1 is just 2. Now, I have all integers. So now the way typically I write my answer, remember, this is a plus or minus sign. So this means I'm going to do negative 2 plus 10 and then divided by 2. That's going to give me one of my answers. Let me erase that. It might be in the way. You know how you be checking to see if your markers work, you know. Anyway, and then another answer is going to be negative 2 minus 10 divided by 2. So I'm going to have two answers, right? So usually people do like this. They do the two arrows drawn, right? Like that, right? So what's negative 2 plus 10? Negative 2 plus 10 is positive 8. And then you take that positive 8 and divide it by 2. So you got 8 over 2, which equals 4. So 4 is one of my answers. That's one of my solutions, but it's a quadratic. Fundamental theorem of algebra says that I should have just as many solutions as is my biggest exponent in the problem. My biggest exponent is a 2, so therefore I should have 2 solutions. Now I got to use the minus sign. Negative 2 minus 10 is negative 12. Negative 12 divided by 2. Oh, I jumped the gun. I jumped the gun and wrote the answer in the denominator instead of writing 2. Happens a lot. Happens to the best of us. Get in there, man. All right. Negative 12 divided by 2 equals negative 6. So this should be my solution set. 4 and negative 6. Now this is not a point, right? This is not a point. This is not a point to be graphed on a coordinate plane. This does not mean x is 4 and y is negative 6. That means I have two solutions. One of my solutions, one of my values of x is positive 4, and the other solution is negative 6. And we can go ahead and check our work, right? Which I always recommend. I always recommend us checking our work. Because when you check your work, you don't got to ask nobody if your work is correct, because you already know it's correct. You know it's legit, because you checked it. All right? So we're going to check our work, right? So we plug in, let's say I want to check 4. I'm going to make sure 4 is correct. So that means that 4 squared plus 2 times 4 minus 19 should equal 5. So let's make sure that's true. 4 squared plus 2 times 4 minus 19 equals 5. And is that true? 4 squared is 16. 2 times 4 is 8. Then minus 19 is equal to 5. 16 plus 8 is 24. 24 minus 19 is 5. That's true. So we know 4 is good. We're going to do the same thing with negative 6. Now, replace that x with a negative 6. It's a negative, so use parentheses. Whenever your value is a negative that you're substituting, use parentheses when there's an exponent involved. Use parentheses when there's an exponent involved, because negative 6 in parentheses squared is not the same thing as negative 6 squared with no parentheses. It's not going to give you the same answer according to the order of operations. And that's another thing that we should always also be very well versed in, the use of the order of operations and the correct usage of the order of operations. So we got negative 6 squared plus 2 times negative 6 minus 19 equals 5. Now the question is that true? Negative 6 squared is positive 36. 2 times negative 6 is negative 12. Minus 19 equals 5. 36 minus 12 is 24. 24 minus 19 equals 5 again. We already know 24 minus 19 equals 5, and we get the same equation again. So this is also good. So that's proof that our answers are correct. And ladies and gentlemen, boys and girls, this is how you use the quadratic formula. Again, memorize this formula. Do yourself a favor. Memorize this formula. Do a whole bunch of problems involving and requiring you to use the quadratic formula. Also, every time you do a problem, let's say your teacher gives you an assignment with 10 examples. Well, they probably wouldn't give you 10 examples. Maybe 5 examples, or maybe 5 or 6 or 4 or 5 examples. Every time you use the quadratic formula, I suggest, this is like, like a life hack, right? Write the formula down over again every single time. I know it's going to be written down at the top of your paper and you're just going to be able to refer back to it. That's cool. I get it. But until you have it memorized, keep writing it down over and over again. Because years from now, or like you might be in middle school right now, you might be in elementary or whatever, when you're in when you get to high school, you want to have this formula memorized. All right? So you don't got to think about what it is. Because that's the easy part. Just knowing the formula, that's the easy part. You want to make sure that's the easy part. But if you don't have it memorized, then that's going to become the hard part. You don't want just knowing the formula to be the hard part. All right? So, again, continue to send your math problems to the All This Math inbox. Your problem might make it up to this board. Thanks for tuning in. Again, shout out to Lincoln University. This is Professor Parker. I'll see you later.